Well, hello students. This is the study guide I put together for you for the test 2, which is the second unit we've done, which is on quadratics. There will be another one that we will do eventually. But at any rate, I'm very confident that if you will watch this thing, practice it with your own study guide I provided, you'll do fine on the test. So I'm going to go through this pretty quickly, but hopefully clearly enough. All right, question 1. If the leading coefficient of a quadratic equation is positive, the parabola will open up or down. So for instance, if you've got an equation like 3x squared minus 6x plus 2. This 3 is the leading coefficient, and it's positive, so that means the parabola is going to open up, like so. All right, number 2. What algebraic steps would you take to find and graph the vertex of this? Okay, now this is going to be like a multiple choice kind of deal. All right, so we have a standard form quadratic equation. The very first step will be to find the axis of symmetry, which is negative b over 2a. Well, my b number is negative 4, so it's going to be a negative 4 over 2 times my a number is 2. So a negative 4 is a positive 4 over 2 times 2 is 4, so 4 over 4 is the number 1. All right, what that means is that the x value of the vertex is going to be 1, because the axis goes right through it. Now, how do we get the y value? Well, you take that number 1 and you plug it in here and here. So you have y is equal to 2 times 1 squared minus 4 times 1 plus 6. Now what is that equal to? Well, 1 squared is 1, 1 times 2 is 2. 2 minus 4 would be negative 2 plus 6 would be positive 4. So that would be the vertex right there. So quick review, you start with the axis of symmetry, you find what x is equal to, that becomes the x value in the vertex, you plug x in to the original equation to solve for y, and whatever number you get, there you have it. All right. Now, number 3. Which of these equations shows a stretch transformation? Which of these shows a compression? Well, let's review it. Let me see if I get a different color here. This is kind of cool. All right. So if that's the parent function, then a stretch will get skinny. That's a stretch, it gets skinny. And I don't know, let's pick purple. A compression makes it wide, flatter. Okay, now, what makes a compression? What makes it flatter? When the leading coefficient is a fraction, less than 1. So it could look like that. It could look like that. As long as the number is less than the number 1, then it's going to flatten out from the parent function. A stretch, on the other hand, let's go back to red, light red, is when the leading coefficient is bigger than the number 1. And if you ever forget, just plug in a couple examples into your graphing calculator and take a look, and it's like, wow, it's right there. So if a number is bigger than 1, it's going to make it skinny, or called stretch. Now be careful, because For instance, a number like that, and you're thinking, oh, that's a fraction, that's got to be less than 1. No, no, no. That actually 5/3 is 1 2/3. So it's a bigger number than 1. So that also would be a compression. So let's go back now to our questions. Which of these is a stretch? Well, this notation may be kind of weird to you, but this is the kind of notation you get when you're not using equation editor, when you're just using a regular keyboard. This means 2x squared. The little caret symbol means to the second power. So notice the leading coefficient is bigger than 1, so that's a stretch. All right, here we have 0.4. That's smaller than 1, so this is a compression. 5/3, it just dealt with that. That's a number bigger than 1, so that's a stretch. And here we've got 1/2 x squared. So that's obviously less than 1, so that's going to be a compression. All right. All right, number 4. Where are these functions increasing? Where are they decreasing? Well, let's draw an imaginary line right through here, right through the vertex. This would be the axis of symmetry. Can you see that from this point to the right, the red line is going up, it's getting bigger? So, in other words, this whole side of the graph shows where the red line, that branch of the parabola, is actually increasing. So how would we describe that? Well, at what point does it increase? Well, it starts where x is 4. Remember, I know we're looking down here, but that's a y value of what? -4? We're not worried about the y value. We're just thinking the x values. So, you know, coming from infinity left, come. All right, once we get to 4, then that thing starts to go up. So we would say it increases from close bracket 4, and then continuing to the right forever, positive infinity. Where does it decrease? Well, it decreases all on that side. So it decreases from, open parenthesis, negative infinity to positive 4. All right, let's look at this one. It's a negative leading coefficient. That's why it's opening down. Would you agree that this is the part that's going up? Well, where did it start? Well, as it went down, it's also going out. So it actually started over there in negative infinity. So it increases from negative infinity all the way until you get to positive 4. Boom. That's when it peaks out. So that means from here to the right is where it decreases. So it decreases from positive 4 to positive infinity. It's actually just the opposite of that one over there. All right, so describe the transformations of each of these parabolas from the parent graph. Okay, well, let's remember where the parent graph is. The parent graph is centered on the origin. So it's going to look more or less like that. So how did you go from this blue, the parent graph, to the red? Well, the first thing we did is it flipped, right? So in terms of this particular one, we would say a reflection, comma. Then the vertex shifted 1, 2 to the left. And then once it got there, it went up how many? 1, 2, 3, 4. All right, same deal here. Let's sketch in the parent function right there. All right, how did we go from the parent function to that one? Well, it didn't flip, it didn't reflect, so that's cool. So I think you would agree it went left. It went left 3 and up 1, 2, 3. So, in other words, I want to give you that equation. Let's understand. If this blue one is y is equal to x squared, the red one is y is equal to x plus 3 squared plus 3. Remember, in vertex form, it's always the opposite. If it's plus 3, that meant it went left 3. The vertex would have been negative 3, 3. And that's something you want to keep in mind for a later problem. Okay, so I need to erase all this stuff. Let's see if my eraser thing works. Yep. That's kind of cool, isn't it? Not as quickly as I'd like it to, but that's all right. All right, there we go. Yeah, I'm already tired of doing this. Come on, eraser. I need a bigger, fatter eraser, don't I? All right, the reason I erased it is because, well, I don't know why that one didn't move. Which graph above could represent a reflection across the x equals -1 line? If the preimage was that equation. Well, first of all, let's draw in the x equals -1 line. All right. All right, that's the x equal -1 line. And there it is here as well. All righty. Now, the preimage, remember, that's where you start. If it started here, well, what is that vertex? That vertex is +1, +3. So let's locate that. +1, +3 is right there. +1, +3 is right there. Now, a reflection across the x -1. Well, that would be 1, 2 to the right, 2 to the left. So yes, this reflected over. Now, many of you could have realized early on this one could not be it because it was going down. It was a flip. And the question didn't ask for a reflection over anything on the y-axis. It asked for the x-axis. So that's it right there. So it would be, yeah, there we go. All right, so let's go on up. Oh, for crying out loud. All right, which quadratic functions below have a vertex in quadrant 2? Well, this goes back to math 1, so let's remember the coordinate plane. We have quadrant 1, Roman numerals, 2, 3, and 4. So they're asking which has a vertex somewhere in that quadrant. Well, what is this vertex here? That's -2, 3. What's this vertex? -4, -3. What's this vertex? We got to solve for this one. So let's go. X is equal to -b over 2a. And so that's going to be +6 over 2. So that's going to equal 3. So we plug in the 3 here. And we get 3 squared is 9, minus 6 times 3 is 18, so that's -9 plus 8. Let's see, -9 plus 8 would be -1. All right, so that's that vertex. Now, which of these vertices lands in quadrant 4? Well, -2, 3 would be up here, quadrant 2. Oh, that's what we're looking for, not quadrant 4. All right, so negative 2, 3. So yes, this one would definitely be there. How about negative 4, negative 3? That would go here and then down. So no, that's not there. How about 3, negative 1? No, that's not, because that's down in quadrant 4. So turns out that's the only one that has a vertex in quadrant 2. All right, now I'm going to change the screen here in just a moment. I hope I can remember this. 150x minus 5x squared can be used by a company to model the profit. So the profit is on the y-axis, where it charges X dollars per item. So that's going to be on the x-axis. How much should the company charge per item to maximize profits? All right, so let me go now to the graphing calculator. I hope this will work. So I'm looking at 150x minus x squared. All right, let's see, it should be down here somewhere. There we go. Whoops, that's not what I want. There it is. Okay, so I want to go to the y equals menu and type in 150x plus x squared. All right, now I'm going to hit zoom 6. Didn't see too much, did I? I did see one branch coming up here. Now, when that happens and you can't see the parabola, here's what I want you to do. I want you to go to zoom 0. And that will attempt to put it up there, at least enough so that you can adjust it. Now that looks like a straight line. Did I put in my x squared value here? No, it's still graphing. Yeah, I did. Okay. Well, that's going to need a whole lot more x max and a good bit more y max. So we go to window to reset the window, scroll down here to x max, and I'm going to type in 50, and then y max, I'm going to come down here. Oh, it's already at 1600. That's not going to be enough, so let's make that 2000. All right, now hit graph. Let's take a look and see if we can see our parabola. We can see it, but man alive. All right, so let's go back and resize the window. Oh, come on, man. All right, y max. I'm going to go ahead and make that 8,000. This is just pure trial and error. Hit graph. Oh, for crying out loud. Well, I'll tell you what. I'm going to give you a different example because this thing is messing me up here. So let's go back here. Oh, I know what happened. This is supposed to be a minus x squared. All right, let me just give you a different example super quick so you can see how the maximum thing works. Let me just clear that out. And let's go with a negative 16x squared plus 5. And we're going to go zoom 6. Now the one in the test works out nicely. This is one that I just created. All right, if you want to find out what that max point is, there's a special program that we've been over once at least, and you go where it's calc, you go second, calc, number 4, the max program, And you need to get that cursor on the left side, and then you hit enter. It wants a right boundary. You hit enter, and then the last time, boom, hit enter 3 times. And so where y is 5 is the maximum value. And had I done that problem right, the peak of that parabola would tell you exactly what x value would create the maximum profit. So sorry about that, guys. Let me go back. Let me clear this thing out. Let's go second quit. And let's go back to where I was here. Yeah, it was negative 5x squared. I messed up. Oh well. Let's keep going. All right, so number 9, a ball is dropped from a 300-foot tall building. It can be modeled using this equation, negative 16x squared plus 300. How long will it take the ball to be 122 feet off the ground? How long will it take to hit the ground? Well, you put that in your y equals menu, and what you're going to see is something that's going to look like this. Now, under y sub 2, you're first going to want to type in 122. And that'll be something that looks like that. And so you're going to use the intersection program on the calculator. And let me see if I can show you super quick where that is. Okay, the intersection program is, again, second calc, number 5 intersect. And you remember, you go, it's going to ask for the 2 lines where they intersect, and you hit enter 3 times, and it gives it to you right there. Come on, screen. There we go. Okay, so that's what you're going to do to find out how long. You're looking actually for the x value here, and you do the intersection right there. Then, how long will it take the ball to hit the ground? Well, scratch out that one and make it 0, and then do the intersection program for right there. And the how long, and that will give you the x value there. All right, so what is the solution to this system of equations? Here's what I would do. In fact, this is 1/3 x squared plus 2x plus 4. Yeah, let's go ahead and put it in the calculator. Why not? We got time. 1/3 x squared plus 2x plus 4. Oh, for crying out loud. All right, so let's go to the y equals menu. Clear that out. All right, 1/3, that's going to be 1 divided by 3 x squared plus 2x plus 4. And then under y sub 2, what was it, x plus 2? I think it was. If not, you'll still see how to do this thing. All right, now we go zoom 6, like we've been doing. Now, you could do this algebraically, but it would take a long time. So if you have the opportunity to do it graphically, that's what you ought to do. Okay. Aha! The 2 don't cross, do they? So the correct answer for this is no solution. If they never touch, there's no solution. There's no ordered pair they have in common. Now, had this red line pass through it at 1 or 2 points, then you'd use the intersection program to deal with that. And the same for number 11. All right, number 12, what's the axis of symmetry for this equation? Now, notice this thing is not in a standard form. So I need to add 2x to both sides. I need to add 10 to both sides. So when I do that, let's see here, I've got 2x squared. All right, negative 14x plus 2x is going to be negative 12x. And then positive 10 adding another 10 will be 20, and it equals 0. Now, the axis of symmetry is super easy if you remember the little formula. X is negative b over 2a. Well, my b number is negative 12, so we're looking at a negative 12 over 2 times my a number, which is 2. And so that's going to be a positive 12 over positive 4, so in other words, it's going to be 3. X equals 3 is the equation of the axis of symmetry. Alrighty. Number 13. Here we've got a vertex form equation, and if it's translated 2 units left and 2 units up, the image will be what? Well, let's first graph this thing. Now, what is the vertex here? Well, it's negative 4, negative 2. So, negative 4, negative 2, it's right here. And it's going up somewhere because it's a positive. Now, if we shift this thing left 2 and up 2, where will it be then? Well, if it goes left 2, we're there, and if it goes up 2, we're back up here. So what would be the equation of that? Because we're here at negative 6 on the x-axis and up to 0 on the y-axis, so what would that equation look like? Well, it's going to be f of x. We use that to indicate it's a function. Don't worry, it's basically the same thing as y. So how do we express a vertex of negative 6, 0? That's what we're being asked to do. Well, it's going to be x plus 6 squared. And you could put plus 0, but we typically don't. I would know what you were doing, but that's what the equation would look like. All right, let's keep on rolling. All right, number 14, I'm being asked to write a quadratic function with the leading coefficient of 4 and a vertex of negative 3, 8 that opens down. So we know the leading coefficient is going to be negative. So it says a function, so let's use function notation. You could use y, but I'm going to use f of x. It's going to be a negative 4 because it's going to make it open down. How do we express that vertex? It's going to be x plus 3 squared plus 8. And there you have it. Okay, number 15 is a system, but it's one that we have to use algebra for. This is not one that you can graph. Well, I suppose you could, but you're supposed to use algebra. They want to know what values of x is f of x equation the same as g of x. So in other words, when they're set equal to each other, do they have any x numbers in common? They could have one number in common, they could have 2, or they could have no numbers in common. All right, so what do we want to do to get a big fat 0 there? We want to subtract that x, subtract the 6. So we got x squared plus 7x plus 10 equals 0. Okie dokie. Well, can that one factor? Sure enough, binomial times a binomial. You got x two numbers that multiply to get 5, that add to get 7, x plus 5, x plus 2. Then we use the zero product property and we set each of those equal to 0. So in this case, x is negative 5, and in this case, x is negative 2. And those are the two answers for the x values. All right, number 16. What is the translation that moved f of x to g of x? Well, I can tell by looking at it, but most of y'all can't. So here's what I would suggest you do. Locate the vertices of them individually. So let's start off here. We'll treat this as the parent function. This vertex is at 4, 2, is it not? All right, so let's locate 4, 2, right there. And we know it's going to open up. Okay, well, let's locate this one. This has a vertex of negative 3, 5. Well, where is that guy? Well, negative 3, 5. That's going to be right there. And it's going to open up. So, in other words, from here to here, we first went left how many units? From positive 4 to negative 3 is how many steps? It went left 7. And then once it got up here, how high did it go? It went up. Oh wait, no. My mistake. We're going from here, from 2. This part's right. We went left 7, but once we got here, we were at 2. How many steps did we go up to get 5? We went up 3. All right. Well, let's keep going. Number 17. There are two equations that are presented. How would you know that if I didn't tell you anyway? Well, you got a y sub 1 and a y sub 2. That means in the y equals menu, you got some equation here, and the y sub 2, you got some equation there. This is a system. So where do they intersect, if at all? In other words, do they have any like ordered pairs? I'll try brown. Haven't used that one yet. So let's see. Do they have any? Looky here. This one has 1, 3, and that one has 1, 3. All right, so that's one ordered pair. 1, 3. They both have. Are there any others? Looky here. They both have 4, 6. And so because that's a quadratic, that'll be all. So you actually have 2 ordered pairs. Oh, I guess it just screws in. All right, let's go to the next one. All right, find the quadratic regression from this table of data. Round to the nearest tenth, then predict the value when x is 17. I hope I remember to do that. So let's go to our calculator, if I can find it. There we go. Oh, for crying out loud. That's not what I want. That's what I want. Okay, now I've already built this thing in here, so we don't have to wait for me to do that. All right, so to create a quadratic equation, you go to the stat, edit, number 1. Now I've already put the numbers in here. List 1, those are your x's. List 2, those are your y's. Now we know it's going to be a quadratic regression, but let's create a scatter plot anyway. The scatter plot is under the y equals menu in blue. Man, I didn't even touch it, I didn't think. All right, so let's go second, stat plot. We need to go into plot 1. We need to turn it on. And hit enter. All right, it's been turned on because the word on is blinking. Go to the y equals menu and clear out anything else that was there. And now we're ready to plot the scatter plot. Go to Zoom 9, Zoom Stat. All right, sure enough, we see part of a parabola there, so we're ready to do a quadratic regression. We go back to Stat. No, over to Calculate. I was going to hit number 1, so let's go to Calc. Well, I guess I won't do that. All right, so I'll right arrow over to get there. And I'm going to select number 5, quadratic regression. Now I need to move the cursor down here to where it says Store Regression Equation. All right. Now I need to tell the computer to put it in y sub 1. But in order to do that, you go to vars for variables, over to y vars, number 1 function, and we're going to put it in y sub 1. So I hit number 1 again. Now, I've told it where to store the regression equation, and now I hit enter to calculate. All right, so this equation, I don't think I can write on this one. Pretty sure I cannot. Yeah, I cannot. All right, so you would write it out as y is equal to 1.5 x squared plus 3x minus 2. Now, let's take a look at the graph. We've got our nice line of best fit. But the standard screen only goes to the right 10 units. I asked to predict when x is 17. So what do? Well, go look at the table. It's in blue, so go second table. And we're going to scroll down till we get to 17. Well, it's taking longer than I wanted it to. All right. So when x is 17, the y value we would predict would be 482.5. Let's see, don't need that. Yep. And don't need that. This is what I need. Okay. Which statements, okay, this is the last one. Which statements are true for the graph below? Alrighty. Let's get a different color. So let's deal with A. As x approaches, that's positive infinity. All right. As x approaches negative infinity, meaning as we're going to the left, the y values approach positive infinity. So in other words, as we're going to the left, is the graph going up or down? It's going down, isn't it? Again, as x approaches negative infinity, that's this way, f of x, or in other words, the y values, are they going up, approaching positive infinity? No, they're not. So that one's out of there. All right, how about this? As x approaches positive infinity, f of x approaches negative infinity. Yeah, that's right, isn't it? Because as you're going this way, that thing is going to continue to go down. So we know that B is true. All right, how about C? As x approaches negative infinity, the y values also approach negative infinity, meaning as we're going up here, is it also going down? Yep, so C is correct also. All right, as x approaches negative infinity, f of x approaches positive. No, that's not true because it's going down, not up. And then finally, E, the graph increases from negative infinity to negative 2. In other words, is that where it peaks out? Yes, where x is negative 2, and then from negative 2 to the right, it's going down. So those three are correct. All right, guys, that's it. I hope y'all will review this, and I'm sure you'll do fine. You take care. Bye-bye.